Hi there, I'm Paul. This is Science That Sticks. This is the first video for a long time. Roll the graphic. Hi there, I'm Paul. This is Science That Sticks. Today we're going to go to work on Chemistry Paper 1 for AQA. A few hints and tips on structures of different things. Behind me, I've got diamond, graphite and silicon dioxide or silica. And all three of them are questionable materials. And what I mean by questionable is not as in like that you can't use them for different things. What I mean is students are going to be asked questions on them. So let's go straight towards diamond here. So diamond happens to be an element of carbon or a form of carbon, along with graphite, fullerenes and a variety of other what they call allotropes. You'll notice that diamond has 4 bonds. Right there, it is covalently bonded. Now, the thing that you need to know the most about diamond is that it is a giant covalent structure. That means it contains only covalent bonds, which require a lot of energy to overcome them, which is why it's very hard, which is also why it has a very high melting and boiling point, because a lot of energy is required to overcome those bonds, not intermolecular forces, those bonds, and therefore it has a high melting and boiling point. Next one. Graphite. Well, graphite's in your pencil, not lead. We still call it lead, but it's not been lead for a long time. It's always been graphite. Another form of carbon. It is an elemental form of carbon because it only contains carbon atoms. You will notice that unlike diamond, graphite happens to be in layers. It has delocalized electrons that I've drawn pretty badly there, but what I have drawn pretty right are the hexagon shapes. You'll notice that each of the hexagon shapes has 3 sets of bonds instead of 4. Diamond has 1, 2, 3, 4 covalent bonds around one atom. Graphite, on the other hand, has 3 covalent bonds. The 4th set of electrons are put into a delocalized space. Because it is in layers, it is able to slide over one another, which means it's slippery. Because it has delocalized electrons, which are free to move, means it conducts electricity. So when we compare the two, what have they got in common? First thing they've got in common is that they have only covalent bonds. Second thing that they have in common is that they happen to be giant covalent structures. They happen to have fairly high melting points, fairly high boiling points. Now, the difference between the two physically is that graphite is brittle, whereas diamond is hard. Now let's have a look at silicon dioxide. Again, a very good example of a giant covalent structure. Silicon dioxide happens to have oxygen atoms. Now, you can't see it on my diagram too well in the video, but that's a different shade to this. So I've just got a blank atom to represent the silicon and one that's slightly shaded in to represent the oxygen, making it different from this. This is a compound, so if you're asked to compare the 3 of them, you state that these 2 happen to be elements. This one happens to be a compound because it contains 2 or more different types of atom chemically bonded together. In this case, it's a covalent bond. Once again, it is a giant covalent structure containing only covalent bonds, which require a lot of energy to overcome them. And because it requires a lot of energy to overcome them, and there are no intermolecular forces, it has a high melting point, high boiling point. That is pretty much it. So when you're asked to compare and contrast, you compare by saying how they are the same. You contrast by saying how they are different. Till next time, stay cool. Goodbye.